Hello, and welcome to another exciting edition of the Allaire Report. In today's podcast, we'll be doing a quick review of matter and energy, as well as discussing energy flow, producers, consumers, and decomposers. For Kalani High School, this is the Allaire Report, and I'm your host, Mr. Allaire. Benchmark and Standard 3.3 deals with explaining how matter and energy flow through living things in the physical environment. So I think it's important that we take a moment and do a quick review of matter and energy. You'll remember from last year that matter is anything that has mass and takes up space, and it can be broken down into several different types of units. For instance, atoms are very tiny units of matter that are made up of even tinier pieces of matter called protons, neutrons, and electrons. Now, if you get together a whole bunch of atoms that all have the same numbers of protons, neutrons, and electrons, you've got an element. An element is a pure substance made up of only one type of atom. Now, if you take a couple of elements, two or more elements to be specific, and combine them chemically, you've got yourself a compound. A compound is two or more elements that have been chemically bonded. Some examples of compounds include things like sugar, water, salt, caffeine, and even chocolate. These are all chemical compounds because the elements that make them up have been chemically bonded to each other. Now, matter, remember, is anything that has mass and takes up space. Energy, on the other hand, does not have any mass and does not take up any space. Now, although it doesn't have any mass and it doesn't take up any space, energy does have a drastic effect on matter as we know it. The three most common forms of energy that we'll be talking about in biology and that were discussed in physical science last year are heat, light, and electricity. Now, of course, there are other forms of energy, such as chemical energy that's found in the foods and things that we drink on a daily basis, as well as nuclear energy. Just think of the nuclear power plant that Homer Simpson works at. What's important to remember is that energy does not have any mass and it doesn't take up any space. Now, in dealing with matter and energy, there are two very important laws that you need to be aware of: the law of conservation of mass and the law of conservation of energy. These two laws basically say the same things. The law of conservation of mass says that matter can neither be created nor destroyed, and the law of conservation of energy says that energy can neither be created nor destroyed. Both of these laws are important to keep in mind when talking about ecosystems. Both matter and energy in an ecosystem don't disappear. They simply change forms and are recycled through all of the living organisms throughout the ecosystem. Now, even though both matter and energy are recycled through an ecosystem, it's vitally important to remember that without a constant supply of energy, living systems cannot function. So think for a moment. What is the major source of energy for most of the living things on Earth? For most of the living things on Earth, sunlight is the main energy source. Plants, such as the blue-green algae pictured here, use a process called photosynthesis to process sunlight and create their own food. Now, not all organisms have access to sunlight. Some types of organisms rely on the energy stored in inorganic chemical compounds and use a process called chemosynthesis to process chemicals and make their food. Now, only plants, some algae, and certain bacteria can capture energy from sunlight or chemicals, and we call these things autotrophs, or producers. Autotrophs harness solar energy through a process called photosynthesis. We've talked about this already, so we don't need to go through all the nitty-gritty details. But essentially, in photosynthesis, energy, specifically light energy from the sun, is combined with carbon dioxide and water to produce oxygen and high-energy sugars such as glucose. Photosynthesis is an important process because it not only adds oxygen to the atmosphere, but it also removes carbon dioxide. On land, plants are the main types of autotrophs that you're going to see all over the place. In the water, algae are the principal types of autotrophs that you're going to see. Now, of course, there are some areas that are in between land and water, and the type of autotrophs that you'll find there are what are called photosynthetic bacteria called cyanobacteria. and these are found in areas like tidal flats and salt marshes, generally swampy areas that are sometimes dry and sometimes wet. As I mentioned earlier, there are some types of organisms that don't have access to light. Some autotrophs can produce food in the absence of light. They harness energy not from the sun, but from chemical bonds through a process called chemosynthesis. Now, chemosynthesis is kind of similar to photosynthesis, but a little bit different, but the end result is still the same, the production of energy. These are performed by several different types of bacteria, and these bacteria are generally found in volcanic vents, at the ocean floor and in hot springs, and also in tidal marshes where they may not have access to sunlight due to lots of other plants and organisms around. Remember, organisms that can create their own food from both chemicals and sunlight are called producers. So now it's time for us to talk a little bit about consumers. Some examples of consumers are organisms like animals, fungi, and many different types of bacteria. These are organisms that cannot harness energy directly from their physical environment. We can't get energy from sunlight. We don't get energy from inorganic chemicals that we absorb through our skin. The only way for consumers to get energy is from other organisms. Organisms that rely on other organisms for food and energy are called heterotrophs, or consumers. There are several different types of consumers, and we're going to go through each one of them in a little bit more detail so that you have a better understanding about these different types of consumers and the things that they eat. There are 5 different types of consumers: herbivores, carnivores, omnivores, detrivores, and decomposers. A herbivore obtains energy by eating only plants. Things like cows, caterpillars, and deer are really good examples of herbivores. Carnivores, on the other hand, obtain energy by eating other animals, and only animals. Snakes, dogs, and owls are great examples of carnivores. Now, while your diet may consist mostly of vegetables or mostly of meat, human beings fall into a category called omnivores, and those are organisms that eat both plants and animals. Not only does this group include humans, but it also contains animals like bears and crows. Now, a detrivore, which is something that you may never have heard of, is an organism that feeds on plant and animal remains and other dead matter. So things like mites, earthworms, snails, and crabs are really good examples of detrivores. And last but not least, we have decomposers. Decomposers include things like bacteria and fungi, and these break down organic matter. To recap, consumers include things like herbivores, carnivores, omnivores, detrivores, and consumers. And these are organisms that cannot harness energy directly from the physical environment, so they need to feed off of other things in their environment. Now, when we talk about energy flow in an ecosystem, we're talking about the directionality that energy takes moving from autotrophs to heterotrophs. Energy can only flow in one direction in an ecosystem. It can only go from the energy source to autotrophs, which use the energy from their physical environment, to heterotrophs, which have to eat other organisms to get energy. Now, a food chain is a series of steps in which organisms transfer energy by eating or being eaten. On the other hand, a food web is a network of complex interactions linking all of the food chains in an ecosystem. Now, there are 2 different types of food webs. There are grazing food webs, and there are detrial food webs. Do a quick Google search on grazing food webs and detrial food webs to see what they mean. See what are the similarities and what are the differences, and be prepared to talk about these similarities and differences when we get back together this week. To get a better understanding about the similarities and differences between a food chain and a food web, let's take a look at examples of each. A food chain, remember, is a series of steps in which organisms transfer energy by eating or being eaten. In this food chain, we have algae, which is a producer, being eaten by zooplankton, then small fish, then squid, and finally a shark. A food web is a network of complex interactions linking all of the food chains in an ecosystem. The structure of a food web depends on many different factors, some of them living, for instance the variety and number of organisms in a particular ecosystem, and non-living factors such as the weather, the biome, and the geographic area. Each step in a food chain or a food web is called a trophic level. Producers make up the first trophic level. Remember, producers are organisms that can harness energy directly from their physical environment. They do this either through photosynthesis or through chemosynthesis. Consumers make up the second, third, or higher trophic levels. Each consumer depends on the trophic level below it for energy. For instance, zooplankton depend on the algae to get their energy, whereas small fish depend on zooplankton. The squid depends on the small fish. The shark depends on the squid. Any consumer that follows depends on the shark for its source of energy. In the next podcast, we'll explain food webs and food chains a little bit more, and we'll get into things such as the energy pyramid, the biomass pyramid, and the pyramid of numbers. So I'll see you next time.